All right, so we've spent a lot of time over the last couple of days making sure that we knew how to rewrite equations in factored form using our graphing. And we can also jump from standard to factored form using what's called the sum and product method. So this is a really powerful thing, but it's limited to the form of x squared plus bx plus c. So make sure that you guys get this formula down on your sheet here because it is going to kind of limit what we can work with. Basically, if we have this form, we just find two numbers that multiply to achieve C and add and subtract to achieve B. Let's see what I'm talking about here in this first example. So example 1, we have x squared plus 7x plus 12. So we are going to multiply to achieve this C number here, which is 12, right? So we're thinking what times what equals 12. And those numbers also need to add up to achieve these B's, right? What plus what equals 7. And that B is 7 there. So if we think through this, we can kind of guess and check and think through those ways. You'll eventually land at, hey, 4 times 3 equals 12. And 4 plus 3 equals 7. So I take those two numbers, and that's exactly my factored form. I get x plus 4 times x plus 3. A lot of you like using that little x method where the 12 goes up top, the 7 goes on the bottom, and then we fill in with that 4 and 3 on the sides. If you want to continue using that today, that's totally fine. So example 2, this time we're working with w's. We want to, and I'll use this little x method this time around. Using that x method, we want to multiply to achieve that c, which in this case is 9. I'll make that blue. And we want to add up to achieve that negative 6. Notice how that negative sign comes with it. To do that, we would need to get negative 3 and a negative 3. We'll notice that negative 3 times negative 3 equals positive 9. Negative 3 minus 3 equals negative 6. So that works exactly. So our formula would be x minus 3 times x minus 3. Or if you wanted to, you could write that as x minus 3 squared. Now, you've gotten a lot of practice with that at the start of class, and you'll continue to get it throughout class. But let's push our understanding a little bit more with using what's called our greatest common factors. So when we reach the outside of our limitations here, when the leading coefficient is not 1 or the degree is not 2, we can check for a greatest common factor. So notice in this first problem how we have a 3 out in front of this x squared. And if we go back to our limitations, we needed to have that x squared just with nothing in front of it, or a coefficient of 1. All right, so let's see what I'm talking about with the greatest common factor. If we look at 3x squared, 6x, and negative 24, we can divide out a 3 from all of those terms, right? So let's do that. We get 3, and then we're left over with x squared plus, that would be, let me grab my eraser. If I divide out that 3, we would have x squared plus 2x minus 8. Kind of reverse distributed. Imagine this would kind of, if I multiplied back, that 3 would hit all 3 of those terms. And now I have something that I absolutely can get into factored form here. If I rewrite it, I have 3, we'll keep in blue, and then we can divide that quadratic, which is now in our form, which we can sum and factor puzzle, as x plus or minus something times x plus or minus something. Well, how do we make this jump from here to here? Well, we can do that little sum and product thing where we have negative 8 up top, 2 on the bottom. So we're multiplying to get negative 8. We're adding to get positive 2. In this case, I'm going to need to do, it's probably going to be plus 4 and minus 2, because 4 times negative 2 gives me 8, or negative 8. 4 minus 2 gives me 2. So in here, I'll have x plus 4 and x minus 2. And that's kind of our final factored form. This works the same way in example 4. We don't have a coefficient in front of this x to the third, but it doesn't fit because our degree is not 2, so it's not a quadratic. However, you'll notice that all of our terms have an x in it, so we can divide out an x from each of these terms. Divide out x. So let's take a look at what that looks like. I have an x times whatever's left over, x squared minus 6x plus 9. And then this is something that we absolutely can do with our sum and product puzzle. In fact, we just did it earlier. If I do our 9 up top to multiply 2, adding up to that -6, that gives me -3 and -3. So if I make this jump down here, I still have that x out in front. And then I have two factors here. I'll have x plus or minus something, x plus or minus something, and it's x minus 3 times x minus 3. All right, lastly, some of you are definitely able to push yourself to this type of work. If we run into something that really doesn't work, the table method can be used to support our factoring efforts, and it's a lot more guess and check. So if you look here, we don't fit that form, so we can't use this sum and product puzzle, but we also can't divide out that 2, right? Notice how this 9 does not divide by 2 evenly. So that's not going to work for us. We can't divide out a greatest common factor, but we can do is kind of use this table method that we've used before to kind of go in reverse. So if I was getting this trinomial as an answer, we know we'd probably have a 2 by 2 table to get there. And I know that, hey, one of these boxes, this first box, is going to be 2x squared because I've worked with that table before. And that constant box here is going to be 10. Okay. Now, I kind of got to guess and check and find my way to add up to, we want whatever this thing in red here is to add up to this 9x. So we want our red kind of squares to add up to 9x, whatever they become. Well, so let's start by looking at this top one. If I have 2x squared in this top box, which I'm going to kind of circle in yellow, okay? If I have 2x squared, I'm going to need to multiply something and something to get there. I know both terms are going to have x in them, and I know one of them is going to have to be 2x because we're getting that coefficient, 2x times x. So that can kind of start to fill out our top, right? We know we're going to have 2x up top. We know we're going to have x on the side. Okay, now if I look at this kind of green box here with the 10, actually let me use a purple box to use some different colors. I know I'm going to have to multiply some stuff to get to 10. Well, we could have 10 times 1. That can be an option. Or we could go 5 times 2. That could be another option. Let's test it out with 5 times 2 and see what happens. So I'm just going to throw the 2 up here to start and the 5 up here to start to kind of see how that works. All right. If I work through that, that gives me 10x in that middle box. That gives me 2x over here. But if I add those up, 10x plus 2x, that does not equal 9x here. So that won't work. The 10 and 2 in those orders will not work. Let's kind of back it up because that is not going to fly. Let's just try switching those around. So I go and I'm going to put the 2 on the side now. I'm going to put the 5 over here. So now we get 5x here. On the top right, we get 2x times 2 is 4x. And if I add those things up, 5x plus 4x, that does equal 9x. So I'm all okay there. So finally, our answer is going to be basically this x plus 2 times this 2x plus 5. That is going to be our factored form. It takes a lot of guess and check, but it is a tool that we can use to help us work through the most challenging of problems.